Ever typed a random question into Google? Something like, how many squirrels live in Central Park? Or, what was the #1 song the day I was born? We do it dozens of times a day without a second thought. But what if I told you that one of those simple everyday searches uses more computing power than the entire Apollo 11 mission that put humans on the moon? It sounds absolutely insane, right? How can searching for cat videos possibly be more complex than navigating a spacecraft 240,000 miles through the void of space? Well, stick around, because today, we are rediving deep into this incredible comparison and uncovering how technology has exploded in just a few decades. Let's travel back in time to 1969. The world is watching. Holding its collective breath as Neil Armstrong and Buzz Aldrin guide the Eagle lander onto the lunar surface. The computer that made this possible was the Apollo Guidance Computer, or a GC. This thing was a marvel of its time. It was one of the first computers to use integrated circuits, which were brand new, cutting-edge technology. It weighed about 70 pounds, was the size of a small suitcase, and had a processor that ran at a blistering speed of 2 megahertz. Its memory, it's a whopping 2 kilobytes of RAM and 36 kilobytes of read-only memory. To put that into perspective, a single high-quality photo on your phone today can be thousands of times larger than the AGC's entire memory capacity. The software was literally woven into the memory by hand by female factory workers, a process called core rope memory. It was an incredible feat of engineering, custom-built for one specific monumental task, getting to the moon and back safely. The AGC handled navigation, controlled the spacecraft systems, and helped the astronauts perform complex maneuvers. It was without a doubt the most sophisticated piece of computing hardware on the planet. Now, let's fast forward to today. Pull out your phone or sit down at your laptop, you open a browser and go to Google, you type in your question. Before you can even blink, a list of millions of results appears, perfectly ranked and tailored just for you. What just happened in that split second is a technological symphony on a scale that's as almost impossible to comprehend. When you hit enter, your query doesn't just go to one computer. It's sent out to a massive global network of data centers. These are colossal buildings, some as big as football fields, filled with hundreds of thousands of powerful servers, all interconnected. Your simple question instantly triggers a complex series of events. First, Google's algorithms have to understand what you're actually asking. Are you looking for a definition, a location, a product, or news? This involves natural language processing, a field of artificial intelligence that was pure science fiction in the 1960s. The system analyzes the grammar, context, and even your past search history to figure out your intent. Once Google understands your question, the real magic begins. It doesn't search the live internet in real time. That would be impossibly slow. Instead, it searches its own massive index of the web. Think of it as the world's largest library card catalog. Google has spiders or crawlers that are constantly scouring the internet. 24/7s, reading and categorizing trillions of web pages. This index is unimaginably huge. We're talking hundreds of millions of gigabytes. It's stored across that vast network of data centers. Your search query is then blasted across thousands of these servers simultaneously. Each server searches a small piece of the index and finds relevant pages. But just finding pages with your keywords isn't enough. You don't want a jumbled mess of a billion results. You want the best, most relevant ones at the top. This is where Google's famous PageRank algorithm and over 200 other signals come into play. These algorithms analyze each page for quality, authority, freshness, your location, your language, and whether the page is mobile-friendly. It looks at how many other reputable sites link to it, the user experience on the page, and so much more. This all happens in parallel, across thousands of computers. Once all these servers have done their work, the results are gathered, sorted, and ranked. The system compiles a neat list, complete with titles, snippets of text, and sometimes even a direct answer box, a map, or shopping results. This final organized list is then sent all the way back from the data center, across the internet, to your screen. The entire process, from you hitting enter to the results appearing, takes, on average, less than half a second. To accomplish this, Google is performing trillions of calculations. It's coordinating a global orchestra of hardware and software working in perfect harmony. When you add up the processing power of the thousands of server cores involved in that single search, the amount of RAM used, and the sheer volume of data being sifted through, it absolutely dwarfs the capabilities of the single Apollo guidance computer. The AGC was a solo genius, meticulously designed for a single, complex mission. It did its job brilliantly with incredibly limited resources. A Google search, on the other hand, is like crowdsourcing your question to a global supercomputer. It's distributed computing on an epic scale. So, is it a fair comparison? In some ways, no. The AGC had to work in real time with life-or-death consequences. In the harsh environment of space, with near-perfect reliability, it couldn't just crash and reboot. A Google search can fail, and the worst that happens is you have to search again. The goals are completely different. But the comparison is fascinating because this exponential growth has taken us from a 70-pound suitcase that could guide a rocket to a device in our pocket that can access the sum of human knowledge in an instant. The computing power used for one Google search is greater than all the computing power used by NASA during the entire Apollo program, not just for the Apollo 11 mission. Think about that for a moment. Every calculation for trajectory, every simulation, every piece of data analysis done for that historic decade of space exploration, all of it combined is now surpassed by you searching for a good pizza place nearby. It's a mind-bending testament to human ingenuity and the relentless pace of technological progress. So the next time you type a question into that simple white search bar, take a moment to appreciate the incredible journey that made it possible. From the vacuum tubes of early computers, to the hand-woven memory of the Apollo era, to the global network of data centers humming away right now, that simple search is a small miracle, powered by a legacy of giants and more computing power than it took to land on the moon. Thanks for watching. If you found this as fascinating as I did, make sure to hit that like button and subscribe for more deep dives into the amazing world of technology. See you in the next one.